contributed to raging wildfires, and the temperature would have soared. The environmental devastation would have lasted for millennia. In the end, 90% of the world's biomass burned, and 2/3 of the world's species. The day.
But and we have a couple more summer camps, right, Jeremy? What do we got summer camp?
Yeah, you can load those up.
So
if you go to classes,
yeah, go ahead.
Summer camps, you can look at our schedule, and you can even register online. Next week we have Return to the Edge of Space, which is a really neat program where the students launch a weather balloon. We'll post the results of that video on our YouTube channel, results of that program rather. And this week we just finished up with Gadgets, Widgets, and Gizmos, which was our camp, both of us. And we also have Lab Rat Buffet on August 9th to 13th next week. So we're closing out here, but we had a really successful batch of summer camp programs, and we'll be back next year for more too.
Great, thank you. All right, so yeah, basically, you know, we're actually getting ready for on Monday. We have these tables all set up for our class on Monday. Usually we go to all auditorium style. I said, oh, there's only going to be 30 people tonight, so this is fantastic. Thanks a lot for coming up. So as far as the weather goes, why don't you click on the clear sky clock? There's something called the clear sky clock. So if you want to find out if it's going to be clear or not, you go to this, and all right. So what it means is blue is good, cloud cover, blue is good, white is bad, white is clouds. And then you got transparency, which is basically humidity, how humid it is. So we're kind of fighting that a little bit. So that's actually kind of accurate with what I see going on. All right, well, let's get started. Comets and meteors. Let me give you my PowerPoint. Oh, yes. We don't need that. I will show that Russian video, maybe. All right, so here we go. All right, so things that fall from the sky. That's what comets and meteors are all about. So, so it used to be, hundreds of years ago, people debated about what were these shooting stars, what people call shooting stars in the sky. And, some people thought it was a weather phenomenon, like something in the atmosphere, all right? And now we know that it's basically rocks and dust coming in from outer space, burning up in our atmosphere. And once we got into space and we started looking down, here's the tail of the space shuttle, right here, the tail of the space shuttle. And you can see these features all around the Earth, these circular features that were, tall tale signs of large impact. Anybody been to the crater in Arizona, the Barringer crater? No, okay. I flew over it. I looked down just by chance. I was flying to Phoenix, and there it is. It's like just by chance. So anyway, so things that fall from the sky. So what we're talking about here is that we're talking about small chunks of matter that's orbiting the Earth. Okay, and I got a meteorite. In fact, it's from that crater we just talked about. This came from the crater in Arizona. The crater that it's about a mile across. It's about 600 feet deep. And this is a small piece of the impactor. It was about the size of almost a football field, 80 meters across. It hit Arizona about 50,000 years ago. And just flew out and hit a place called Diablo Canyon. And so we're lucky to have something like this. So you notice, what do you think it's made of? What do you think? Huh?
Iron and nickel?
Yeah, it's iron and nickel. So pass that around. So that's 4.5 billion years old. That's the oldest thing you'll ever touch. All right?
And the coldest.
In the coldest, well, because it's sucking heat away from your hands. But anyway. Now, and we also got here's a slice of a meteor. So another iron meteorite. Now we also got these other stranger rocks. These are called tektites. So when meteors hit, they throw earth rock up into space. And they sometimes rain down. Some might get thrown out into orbit. But this stuff will rain down, and you can see it was molten as it's coming down like a raindrop. Okay, so that's the shape. So tektites. Pass that around. So everybody should get to see that. All right. So
What's this?
So basically, when it's in space, we call it a meteoroid. All right. When a piece burns up in the Earth's atmosphere, we call it a meteor. And then when you pick it up on the ground, we call it a meteorite. So those are the three. So meteoroid when it's in space, meteor as it's shooting down, and meteorite when you find it. What about the ones you don't find? What do we call those? Meteoroids. So anyway, all right. So what's going on here? Most of the time, the meteors you're seeing are not iron. Okay, they're dust from a comet, and this is why we can predict when the meteor shower is going to be. I just got a phone call from downstate. They were asking me, well, how do you know the meteor shower is going to happen really on August 12th? Well, every year around the middle of August, the Earth is moving into the debris field of a particular comet. And this comet we're going to make a comet in a few minutes. You'll see it's made of mostly icy material, and it's really delicate. It falls apart. So it leaves this debris field, and the Earth slams into it every year. So, and August is the Perseids. October is called the Orionids. And I'll tell you why we call them, why we name it after these constellations in just a little bit. November is the Leonids, and then the Geminids. Those are the four. There's about 17 different meteor showers, but those are the four big ones. Okay. So yeah, so rocks from space. So some of them can be quite large. All right. This one right here, this little guy right here, hit this car in Peekskill, New York. True story. It was, I think it was 91, some early 90s, and this girl, her mother went away. Okay, so it was the weekend. The mother went away, and and she had to call her mother up. You're not going to believe what happened to the car, right? So, but they did fine. They sold everything for a lot of money to a museum. So didn't believe it. I got hit by a meteor. So to give you an idea, anybody get to see in the 90s Comet Hailbop? If you saw Comet Hailbop? All right, okay. So each year I ask that, it's like fewer and fewer hands, so I know I'm getting older. So anyway, so this was an amazing comet. I mean, you could see it for months. And I remember living in Endicott, and you could see it hanging out, and you could actually see the blue tail, naked eye. It was really amazing. We've got some great pictures of it here at the observatory. Now, now to really date you, I didn't see this. 1976. Let's see. Anybody see Comet West? So yeah, I wouldn't expect. So Dr. Gaidosh, who still works here, he took this picture March 7th, 1976, Comet West. That was a fairly bright comet. I don't think it was as bright as Hailbop, but again, I didn't see it. So this is Lee Shelf took this picture of Comet Hailbop here at the observatory. If you see our 20-inch telescope, there's a small black telescope on the back of it, and it's an 80-millimeter telescope. And it took that picture. So we used the big telescope to track it really well. But basically we had about 500 people up here. And I said, Lee, you got half an hour. I'll give you half an hour. Take as many pictures as you can. And because we just had so many people. And it turns out that this one was really one of the best pictures of Hailbop in the world. And it's actually in 2 science textbooks. So we're really proud of that. But Hailbop has 2 tails. It has something called a dust tail, and it has something called an ion tail. What's going on here is that we got a dirty snowball in the center here. It's the nucleus, and solar wind is coming. It's hitting the comet, and it's causing the tails. This is debris falling off. The dust tail is debris falling off. The ion tail is caused by the gas being streamed back by the solar wind, and it's energized. It's kind of like the fluorescent lights. Speaking of lights, I'm going to turn this off. So. It's kind of like the fluorescent lights. It's glowing. There we go. Okay. So it's actually glowing. All right. And glowing gas. All right. But anyway, let's make our comet. We're going to make our little comet here. Let me show you. So what's in a comet? All right. So the first ingredients is something called dry ice.
Oh, I've heard of dry ice.
Yeah.
Me too. Cold, it could burn you.
Yeah, it's so cold it feels like it's going to burn you. You're right. So, all right.
Yeah, you gotta wear gloves if you're gonna.
That's right. I got a glove. Here, put this one on. Put that one on. Okay. So, put that one on. Okay. So chop it up for me, okay? Chop this up. So you see this dry ice.
It is ice.
Yeah, see this? So go ahead and chop it up. So yeah, this stuff, so we call it dry ice because notice it goes right from a solid to what?
Chop
So
it,
yeah,
chop
so it
it.
skips the liquid phase, okay? So anyway, so if you melt dry ice, could you swim
It's the
in?
phase from solid to liquid to gas.
So no, so it goes right from a solid to a gas.
Whoa.
And yeah, you don't want to touch it. It's 100 degrees below zero. Okay?
Whoa.
All right. So
Keep chopping it, bud.
yeah. All right, now.
I get to chop
Comets, keep chopping. Comets also have water ice. So what do you think is going to happen when I pour this water in?
I think it's gonna make some.
Okay. And then we also need CO2, carbon dioxide, the same stuff you breathe out. And then I got some crushed up coal to stand for the rocks.
Chop,
So,
Ben, and
there you
chop.
go. Okay, keep chopping up. Keep chopping. All right, let me see how you're doing.
Don't breathe in CO2.
It's not poisonous, but if it robs you of oxygen, that could be a problem. Now, just a little bit more water.
Come on.
All right. And this one I didn't want to do near you because this is ammonia. A little bit of ammonia, not much. And then we'll throw some kitty litter to stand for our rocky material.
Kitty litter.
Okay. Oh, I need. Is that a left-handed or a right-handed? That's left-handed. That's your left hand, right?
Right-handed. I'm right-handed.
Yeah, I need 2 gloves. Here we go. All right. So now we're going to finish our comet. You ready?
Cool. Just keep your face away from the CO2.
Ooh, look at that. Ooh. And here we go. Here's our comet. Now what we're making is not the whole comet. We're making the nucleus of the comet. Okay. Ooh. So in the center of the comet is this big dirty snowball. And it has, and I'll show you a picture of Halleys Comet that a European spacecraft flew by it. I'll show you that. But you'll see darker areas and lighter areas. And most of the time when it's really far away from the sun, so nothing's happening. But once it gets like inside Jupiter's orbit or Mars, it starts getting hit by the solar wind, and so you start getting a tail. Okay. So it heats up, and it's what we call sublimes. It goes from a solid to a gas. And Hailbop's tail, just to give you an idea, was 100 million miles long. So it's gigantic. It was gigantic. The nucleus of Hailbop was 40 miles across, which was the largest comet we've seen. But anyway, that's what a comet looks like. All right?
You show the camera.
Yep. Here you go. All right. So let me show you.
Oh, can I hold it?
No, it's 100 degrees below zero.
Yeah,
Now.
just with the glove.
No.
Okay. Yeah.
You got the glove on. Okay, here. You ready?
Oh.
Yeah, you don't want to hold it, okay? All right. Now. All right. How do you go back one slide?
I can't.
Just with the left arrow.
Left arrow?
Yep.
You don't have
Double.
the,
Double.
Double.
You don't have the gloves on, so.
All right. Oh, there we go. Yeah. So anyway, there's Hailbop. So we made the nucleus. Now, here's what Halleys look like. This is a real picture. This is a real picture of Halleys Comet. All right, and you can see the jet of material coming off. All right. And let's see what we got next. Oh yeah, Rosetta. So we've actually sent some spacecraft now to different comets. Yep. Oh, it's stuck to your glove. I'll take your glove, right? There you go. All right. Thank you. Thank you. So anyway, yeah, we've now gone to more comets and actually touched down some spacecraft on robotic spacecraft on comets, and they're very delicate objects.
Hey,
In fact, hold on. Okay, and a lot of them seem to be just clumped together of material. We're finding asteroids are like that too. They're very, very delicate. Asteroids seem to be almost like, composite gravel piles, so to speak. So here's the surface of a comet. All right. So stardust, we actually flew by and collected it. Comet Wild, dust from Comet Wild. And let me talk more about what's going on here. It's not. There we go. Okay. So here's a typical orbit of a comet, and notice which way is the tail pointing? Which way is the tail pointing? Always what? Away from the sun. So that's because of that solar wind is pressing outward. All right. So, all right. So where do comets come from? You might be asking, where do comets come from? Well, let's go out of the inner solar system. There's something called the Kuiper Belt, which is where those dwarf planets are Pluto and the other dwarf planets beyond Neptune.
Some planets are.
It's even beyond Neptune. It's something called the Oort cloud. Okay, and to give you an idea of, so there's something called an astronomical unit. That's from here to the sun. That's like the meter stick or the yardstick in the solar system. And to give you an idea how far away the Oort cloud is, where these comets come from, you're looking at, they're saying what, about 10,000 AU. So it's really far out there. So it's significantly far. And what it is, it's the leftover material of the formation of the solar system. So comets are pristine samples of the beginning of the solar system. So that's why it's so important to study comets. All right. Any questions? Anybody got questions on what we talked about so far?
What does
Yep.
AU stand for?
Astronomical unit. So from here to the sun. Yeah. So let's talk about the Perseids in general, or in particular, I should say. So if you want to take a picture of a meteor shower, it's good to have what's called a DSLR camera, or some type of camera that can open the lens for 15 seconds, 30 seconds, maybe 40 seconds. Once you start going beyond that, the stars are going to start moving on you. You get star trails. But if you just point it up in the sky, do 30 seconds, it's just luck. I mean, if you get, sometimes you don't even see it, and then when you look at the image later, you'll see a meteor in there. But here's two over our building. So let's talk about some rare occurrences. This has happened during the Leonid meteor shower. Every 43 years, there's a storm that occurs. That comet comes back in, and it replenishes that debris field. And this one was a big one, the Meteor Storm of 1833, where people saw up to 100,000 meteors per hour. And yet it's obviously the end of the world. It was observed by Abraham Lincoln. I saw the storm of 2001, and we saw about 20 to 30,000 per hour. Basically, that was like one every 5 seconds. I mean, you just looked, it was like all over, or 5 every second, maybe. It was unbelievable. But they were faint. It wasn't like they were all, in fact, sometimes you're like, did I see that? But they're all over the place. And we just stayed up all night, and it even got, as the night went on, it got better and better. But that was something else. That won't happen again for a while. So, but that's really related to the Leonid meteor shower. But thanks. And then we have something called fireballs. So whenever a meteor comes down and it's brighter than the planet Venus, we call it a fireball. All right. And I've seen several fireballs. I've seen many fireballs. There was one fireball in particular, again related to the Leonid meteor shower. I was out there in the yard, and I heard these guys yelling in the parking lot, so I ran around the wall, and they were watching this object. It was just like it looked like something out of like a science fiction movie. It looked like a ball, and it was just going straight horizontal like this. We watched it for an additional 15, 20 seconds, and I think that just skipped out of the atmosphere. Okay. We also, a couple nights later, we saw this one right here. We took this picture. It actually exploded. You don't hear it, but you just saw this cloud, and that cloud stayed for 10, 15 minutes. I've never seen that. That was really, and we didn't even have a camera. We went to go we actually had time to get the camera and set it up and take that picture. So you'll want to look for, if you're really into this, you want to look which direction are they coming from, how fast are they going, the color of it. A lot of the Gemini meteors seem to be green. How bright they are, and the train is what we're talking about. That streak is what we call the train. So those are some of the characteristics of a meteor, which you'd look for. So this meteor shower, the Perseids, it's typically 1 per minute, 60 meteors per hour at the peak. Okay, you can possibly get outbursts. The best way to view it is just to really lie down and just look up. Okay, so you don't really look to any particular direction. Okay. You just kind of look around, and I'll explain why that is in just a moment. So here's some meteor. Now here's what happened with this shot. This person who took this probably had it open for about 20 minutes, and so you have to have your camera on a tripod, to keep it steady. And so if you leave it open for a long time, the stars are going to be lines, okay? But you increase your chances of getting a meteor in your picture. Okay. So during periods of high meteor activity, most of the events appear to come from one spot in the sky. We call that the radiant. Okay. It's kind of somewhat of an optical illusion. All right. Let me show you. I think here it is. So let's say here's the map of the sky, and the meteors appear to come from Perseus. That's why we call it the Perseid Meteor shower. But if you're looking over here to the east, where Taurus is, you would just see the meteor come this way. Well, let's just say if you had a map, and you, as the night went on, you traced where you saw all the meteors, right? They would suggest this. You follow them back to this point right here, okay? So, but it can appear anywhere in the sky, right? So you can be. So look, they're all over the place, but they just appear to come from Perseus. So that's pretty much how to describe that. Any questions on this? So you look anywhere, wherever it's clear. That's really the best thing to do, wherever it's clear. Well, that's it. So that's pretty much it. All right. Let me show you a quick video. I have a little video on. There was an event does anybody speak Russian? Okay, good. There's some bad words in here, I think. So I can play it if you don't speak Russian. So anyway, so in Russia in 2013, I can't believe it's that long, a huge meteor about the size of one of those small school buses came down, and it was a daylight fireball. So. There's the train left by it. So a lot of people were up there looking at. Yeah, you just heard all the windows break. So they're looking at this thing, and the sound wave takes longer to get to you, right? Because you see the light right away. And it just broke a whole bunch of windows. Nobody was killed, though. There was a lot of injuries. About 1,000 people got injured, mostly by flying glass. So, it's driving along, and then suddenly, where is it? Oh, there it is. It's over there to the right. You think it's like the sun. Wow. Okay, these guys are shoveling snow. Yeah, these are mostly car views. Maybe this wasn't the video I was thinking of. But there's a couple of good ones where a lady was in a job interview, and it was all the windows blow out. It looked like a job interview. So it basically exploded in the sky. They did find some debris in a lake, but didn't recover too much. So. Look at the shadows. Yeah, look at that. So in broad daylight. Right. It's Siberia. It's winter all the time, bro. Okay. There it is. That's the shockwave. Yeah. Yeah, and a lot of people were surprised. They didn't know what it was. They didn't expect that. They're just looking at this cloud. That's a classic shot right there. Right. I know. Look at that. Yeah. 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 Oh yeah, here we go. This is. Wow, yeah, it knocked them to their feet, off their feet.
You got it.
Okay. Okay. What's that? Okay. Oh, okay. Okay, let me just. Am I still on? Yeah, that's. It's almost done. And actually, you know what? That ends my program. I mean, it's basically ends my program. So how do you want to do this?
All right, then we'll just. I'll announce it.
Yeah, I'm done. That was it. Okay. So how are we on telescopes? Okay, so what do you want me to do?
So if you just want to close out, I'll make the announcement.
What are you going to make me now? I mean, I got it here.
Okay.
Yeah. So folks, that's pretty much it. It's still kind of getting dark. Is Venus out?
It's there were some clouds out there last I checked, but
so we're kind of in this weird twilight time. I'm trying to get Venus in the 6 inch. I'll try to do that at some point. Once it gets totally dark, I'm going to. I got a laser, and I'll do a laser constellation talk. Okay. And the main things we're going to watch tonight, it does look kind of good though, right? We're looking okay, the clouds?
yeah.
Okay, so, I mean, we're fighting some clouds, but the main objects we're going to get is Jupiter and Saturn. So definitely stick around for Saturn's out first. Venus is over here. I'm going to get that in first. And then we'll get Saturn, and then we'll get Jupiter. But at some point, we'll go in the backyard, and I'll show you some constellations with my super bright laser. And then, of course, kids who got here late, we have an activity in physics to glow-in-the-dark coloring. So if you want to do that, that's fine too. Okay, Jeremy's got a special announcement. I'll peel off just to make sure what's going on outside. We're ready to
Okay,
go.
apologies, ladies and gentlemen. It's something we miss, although we do have our sign up as you come in. Anyone that is unvaccinated, primarily kids, we do have to have masks at all times at Kopernik. So if that is the case, thank you for your understanding on that front. We have boxes of masks. I have some up here if you need a mask. Please mask up. Again, if you are unvaccinated, we want to stress that. To keep everyone safe as possible. We are a science center up here, so we want to support that effort. Okay, thank you again. And please, again, if you're unvaccinated, mask up. Come to one of us, either Laura in the back or me, Jeremy, in the front. Thank you again, and we'll go out to the scopes otherwise.
I want to get their picture.
Oh, our meteors, yes, thank you.
Yeah.
You just put them right up on the screen. Thank you so much.
There was another flat one. There we go.
Thank you so much. Okay, very good. Thanks so much.
Yeah, let's get your picture. Bennett. Here, bud. Can you stand over there? I want to get your picture with you.